and especially thank you very much to our speakers. Let me really thank them for their impressive presentations, sharing so much insights with the participants. I think we have some minutes left for some short questions. Maybe speakers still on board may switch on their cameras so we can have a short interaction. And yes, I'd like to begin with one question of the audience for Mr. Schimmel from Guidehouse. Participants were really impressed by your cost comparisons, especially in regard to pipeline distances. The question was, is there a maximum distance? A pipeline between India and Germany would have a length of at least 6,000 kilometers. So question, is that technically and economically feasible? Politically, certainly it's another question, but yeah, maybe you could shed some more light on this, please.
Yeah, thank you very much for that question. I mean, in theory, yes, that would be possible. There are gas pipelines, for example, one in India that is 8,000, in China that is 8,000 kilometers long. And then a theoretical hydrogen pipeline wouldn't need to run all the way from India to Germany. So I would say that Turkey would be enough, and then from Turkey you would have already existing pipelines that you could rededicate to hydrogen. So there is the Anatolian pipeline that goes into the TAP, the Trans-Adriatic pipeline that would then go to Italy, and then from Italy there are multiple pipelines operated by Snam, for example, that would go into Germany. So it would then need to be a pipeline from India mostly to Turkey.
Okay, thank you very much. Maybe right away in connection to this question, another question was on transporting hydrogen directly via ships. Is there any hydrogen ships, transport ships already coming up or in use, or are you calculating mainly with transport of ammonia via ships?
So the transporting of hydrogen is still being developed. As far as I understand it, I mean, there are certain companies, especially from Asia, that are quite far already in developing liquid hydrogen ships, for example. You could use containers. That's already possible today, but that's not the most cost-efficient way. And in terms of ammonia via ship, that already exists today. So ammonia is a global commodity, it's traded globally, and those ships exist. What does not exist today is, of course, ammonia ships that run on ammonia as a fuel, because in Europe, we're looking at the life cycle emissions, so not just the emissions of ammonia or hydrogen, so also the emissions that were emitted during transport. So their fossil fuels would not be the best option. So their development should also go towards developing ships that run on either green hydrogen or green ammonia or green methanol.
Yeah, thank you very much, Mr. Schimmel. Next question is for Ms. Debacher from Hamburg Hafen. Participants were pretty much impressed about your approach of being a consumer of hydrogen on the one hand, and certainly on the other hand, which was a focus of this session today, handling of large amounts of hydrogen. Regarding consumer of hydrogen, a question of the audience refers to these 100 heavy-duty vehicles. You mentioned the H2Load program. Is there a timeline where you would like to have these vehicles in place? And then another question was on how much actually battery electric vehicles you already may have in use or are planned. So in comparison a little bit to hydrogen.
Yes, of course there's a timeline, but it kind of depends on when these vehicles will be available as a prototype, because the difficulty is that we first have to develop them, test them, but we hope to have them available very soon. And then we plan to put these more than 100 fuel cell vehicles into operation within the next years. But to add on that, of course, battery electric also plays a big role, and we are already way further ahead in electrifying our vehicles. It always depends on the type of operation. So, for example, we have one terminal, that's the container terminal Altenwerder. There we use a lot of AGVs, they are called, automated guided vehicles. They're basically like autonomous trucks. And there, the two factors that play an important role are charging time and also the grid, the power grid. And for these AGVs, the charging time does not play that a big of a role because they drive autonomously and we don't have that much idle time. And that is also the reason why we have already electrified those vehicles. So we have more than 60 battery electric automated guided vehicles on our terminals and have therefore also been certified as the world's first climate neutral container handling facility with our container terminal Altenwerder. But our other terminals, they have different operation systems, and there we see potential also for hydrogen. But if battery electric is an option or it's the easier way, it's of course the more efficient way to use the battery electric systems.
Yes, thank you very much, Ms. Debacher. Very much impressed, and all the best for your ambitious goals. Then there is a question on security, on handling of hydrogen. Mr. Bargest or Mr. Wilms, if you're still there, really planning these terminals. We saw that you're still considering to go maybe via the ammonia route and not storing the hydrogen directly. Is that already decided, or are you going a parallel approach? And then the question from BHL, Mr. Tivari, here in regard to security and storage of hydrogen, if there's any testing ongoing in Germany, is there any norms for green hydrogen or any form of hydrogen storage and transport? Mr. Bargest or even Mr. Schimmel or Mr. Schneemeier, if you would like to answer these questions.
Well, I can take it up from the experience that we've made. So obviously, whether you store ammonia in big amounts or hydrogen, both of them bear some risks and require very careful security prerequisites. Obviously, there is companies in the market that can actually assure that risk. To my knowledge, hydrogen storage in large scale as a liquid or gaseous hydrogen is not in place yet. At large scale, I'm speaking about, I don't know what, 50,000 cubic meters or whatsoever, so really big tanks. And when we discuss ammonia, it's also a different but very similar question. It's also a dangerous substance, which is not only poison but also highly flammable. So obviously there is applications in place for ammonia storage, but currently when I focus on Hamburg, there is no real reference project where even the local authorities can draw back and on any experience. So the question currently is, what would it imply to store ammonia in large scales? And the second thing is, having ammonia is one thing, but at one point you then need to crack it to actually have again hydrogen. And this would likely also imply that you would also need to have some storage opportunities for hydrogen. So there's even two perspectives when it comes to security risk. On the one hand, potentially large storage amounts for ammonia, and on the second hand, also then probably in the same place even for hydrogen.
Yes, thank you very much. Then I don't know if this is maybe too much of the future. There's a question on last mile hydrogen transport in form of other carriers, or maybe metal hybrids, carbon nanomaterials, or solid state hydrogen storage systems. Is there already any considerations in regard to that, or are we speaking about too much about the future here? Maybe Mr. Schneemeier from Fichtner, or also Mr. Bargest, Mr. Wilms. whoever might like to take this question up. Mr. Schimmel from Guidehouse.
But the only thing I can say is I've heard that there is also this way of using metal hydride as a carrier, but that's not what we have looked at. So I cannot really give any fundamental statement.
Okay, thank you very much. Mr. Schimmel, anything from your side in terms of any alternatives to hydrogen or ammonia so far?
Yeah, I mean, we did look at the metal hydrides in one of our analysis, but I mean, the technology readiness level is still quite low. So it's really only something that probably would be feasible in the mid to long term. So in the short term, short distance hydrogen is really either compressed, liquefied, LOHC, or in its derivatives, so ammonia or methanol e-fuels. And then further applications are still in development, but we don't really see them in the next few years.
Thank you very much. We are still within the academic quarter of being a little late closing the session now. Yeah, let me once again thank the Indo-German Chamber of Commerce for having organized today's webinar. Guidehouse for your impressive presentation on cost comparison. All speakers from EVOS Hamburg GmbH, Oiltanking, Fichtner, Linde, Ms. Debacher from Hamburger Hafen and Logistik AG. Thank you very much for your time. We would like to also thank our media partner, Fuel Cell India, who is covering this series of events. Recommendation to actually just check out their magazine, Fuel Cell India. You'll find it right away. Searching for it in the internet. And yes, with this, once again, thanking also the Ministry for Economic Affairs and Energy in Germany, who has made this webinar, this knowledge session on transport of green hydrogen possible. And yes, looking forward to see you all again for our next session, Teresa, I think on hydrogen carriers. So there we will dig deeper into the chemical sector and to which extent hydrogen may play a role in petrochemical and fertilizer, but also in terms of different energy carriers based on hydrogen. So once again, thank you very much, and looking forward to see you again. Vir Melenge.